As the title states, it's all about factoring polynomials. The focus will be on binomials, which is a polynomial of 2 terms, and trinomials, polynomial of 3 terms. And there'll be a few where we have grouping invalid, so we'll have more than 3 terms. But for the most part, it'll be binomials and trinomials. So you can pause the video, try to work some of these out. If I'm going too fast, pause and rewind and so forth. Let's look at the first one. We have 2 terms. It's a binomial. First thing you want to look for is a common factor. Is there a term? It could be just a number, or it could be a term like 2x or 5x that's common to both terms. You factor it out. So in the first one, we have 3x minus 6. You can see 3 divides both of the numbers, or both terms. So we take out the 3. And what's left? Well, the 3x has a coefficient of 3, so we took it out. And then 3 goes into minus 6 2 times. And just visually check yourself. 3 times x, give me 3x. Remember the coefficient here is a 1. Once I take out the 3, 1 multiplies the 3. It's the identity, it stays the same. So 3 times x minus 2, took a common factor. And sometimes you look at the inside, what's in the parentheses, and sometimes that will be factorable. In this case, it's not. The next one, very similar. We have 7x minus 14. You can see 7 and 14. I'll ignore the sign for right now. 7 and 14 have a factor in common, which is 7. So I can factor out the 7. What's left for the first term? We have an x. Take 14, I leave the minus there. It's understood there. Okay, 2 times 7 is 14, so if I take out the 7, I'm left with 2. And then just mentally check yourself, multiply through. 7 times x is 7x, 7 times minus 2 is minus 14. Let's clear these. So we're going to go to number 3. We have 2x, again, first few are all binomials. 2x squared minus 2x. Look for the common factor. Sometimes they call it the greatest common factor, GCF, because we want to take out the largest possible factor. So we have 2x squared and a minus 2. So again, I'm ignoring the minus, but this part is there. 2 and 2, of course, are common. So we take out the 2. Now, you can see that the first term has an x squared, the second term has an x. So you can definitely factor out 1x, or x to the first. What's left? So we took out the 2 from the first one, so that's gone. Coefficients begins, I don't put the 1 there, but it's understood to be a 1. And then instead of x squared, you get an x. Now in the second term, you took out the 2x. I'm leaving the minus for now. Okay, that's minus there. So we took out, what, 2x, so what's left? Remember, 1 always multiplies anything. 1 times anything is that anything. 1 times 10 is 10. 1 times 2x is 2x. So you don't leave it nothing or 0. You can know, check yourself. 2x times x is 2x squared. And if you don't have anything there, there's nothing to multiply. So it's a 1 or a minus 1. 2x times a minus 2, or 2x times a minus 1 is a minus 2x. That checks. The next one, also a binomial. ax minus a. What is that equal to in factored form? Well, you can see a is common to both. Take out the a. First term leaves me with an x. And then I got a minus. Take out the a, what's left? It's not 0. It's a 1, because 1 times a gives you a. That's the factorization for that one. Now, for the next one, we want to look at some formulas. I actually looked at these formulas in another video. We were looking at multiplication of polynomials, and I mentioned in that particular video that this is going to lead to these types of formulas. And let's look at the formulas that we have here at the bottom. There's the first one. This is these first 3 apply for binomials. A squared minus b squared. Anytime you have this formula, tells you anytime you have the difference of 2 squares, one factor will be the difference of the square roots. The square root of a squared is a, the square root of b squared is b, and the sum of the square roots. So it's the difference in the sum of the square roots. A minus b times a plus b gives you a squared minus b squared. We looked at that in an earlier video. The second one tells me if I have the difference of 2 cubes, a cubed minus b cubed, the first factor will always be the difference of the cube roots. So the cube root of a cubed is a. The cube root of b cubed is b. A minus b. And the second factor will always be the square of whatever you put right here in the first position. That's an a, so it's a squared. And then notice the signs change here. Plus the product of those two roots, cube roots in this case, ab, plus the second root squared. Notice for the sum of two cubes, the formula is very similar, except for the sign. Sum of two cubes, first factor is the sum of the cube roots, and the next factor is the square of the first one, and then to get a plus, like in the previous one, is a minus the product of those roots, ab, plus the second root squared. These are your formulas. You should memorize these. We left off with number 5 rather. 5, I have the difference of two squares, x squared minus 36. Now notice you might have a common factor, so look for the common factor or the GCF. We don't have anything, so it's definitely the difference of two squares. X squared, obviously the square. 36 is 6 squared, so it's a square. So according to the formulas the formula we just looked at, one factor should be the difference of the square roots. The square root of 36 is 6, so x minus 6, x plus 6. And notice these don't have to be in this particular order. This is correct right here, x minus 6, x plus 6. You could write the x plus 6 first, and then x minus 6 second. It's still the same, just like 2 times 3 is equal to 3 times 2. The next one, have the difference of two squares again, 25x squared. Obviously that's a squared, because 5x squared gives me 25x squared, and of course 4 is squared. 2 times 2 is 2 squared. So the first factor will be sum or difference, doesn't matter here. I like to write the minus first, so 5x minus 2 and 5x plus 2. Now when you do these, multiply it back in your mind. Okay, 5x times 5x is 25x squared. 2 times minus 2 is minus 4. And then multiply the middle terms there, minus 10x. And over here, that's a 10x. Minus 10x and a plus 10x cancel. Gives me the middle term to be 0x, so we don't put it in. Now the next one, we have a difference, no common factor. No common factor. So we look for difference of squares. When you have a binomial, look for difference of squares, look for difference of cubes, or sum of cubes. In this case, we have a difference of cubes. X cubed and 27 is 3 to the third, so it's a cube. So the first factor should be the difference of the cube roots. So that's x minus 3. The next factor should be the square of that first term and that first factor there. So it should be an x squared. Then the sign changes from here from a minus to a plus. And the product of these two, 3 times x, so it'll be 3x. Plus 3 squared, that's 9. Okay, let's clear this. Now the next one, you have 8x to the third minus 125. Well, 125 is the same thing as 5 to the third power. So these are difference of cubes. No common factor to take out. So the first factor should be the difference of the cube root. So this will be 2 x to the third, or just 2x I should say. The 2x cubed gives me 8x to the third. And the cube root of 125 is 5. But once you get your first factor written, then the next one is derived from just using the terms here. So it's the first term squared. 2x squared is 4x squared. And the sign change, that's minus, it goes to plus. It's the product of those two terms. That's 10x plus the last term, 5 squared. That's 25. Now the next one is very similar to number 8. But instead of 8x to the third, it's 8x to the fourth. Instead of just a minus 125, it's minus 125x. So here what you want to do is take out the x, common factor. So what does that leave me with? That leaves me with 8 x to the third minus 125. So I have then in the parentheses 8x to the third minus 125. Well, that's the same thing as this. So this, of course, is going to be x times, and then it's just the same as what we have here. So this factor here would go right in here, and that would be your answer. So always look for that common factor, and then see if what you have left in the parentheses factors, in this case it does, difference of cubes, that's your solution. Okay, now we get to trinomials. Now we'll look at first, most of these are going to be the first two here with where the coefficient of the square term is a 1. Those are the easiest ones to factor, because if the coefficient of the square term is a 1, then all you have to do is find factors of the third term, or the last term here, that add up to this middle term. So look at the factors of 8, and 1 and 8, I should say, or 8 and 1, whatever. 4 and 2. And you can list some more if you want. And you can ignore the minus, that comes in later, but you can see that you want factors that multiply to give you the 8, the third term, and add up to the middle term. Well, 4 times 2 is 8. 4 and 2. Let me put it this way. The factors of the first term are going to be x and x, assuming the coefficient of that lead term is positive 1, which it is in this case. First, the factors here for the first and the second, it will always be x and x. And then if the third term is positive, which it is right here, these signs should be the same. These signs should be the same. Well, since we have to get a positive 6x out of this should be a plus and a plus. And you can put the 4 here or here, it doesn't really matter. It's going to come out the same either way, so let's put the 2 there and the 4 there. And then check yourself. X times x is x squared. 2 times 4 is 8. And then right here, 2x, that product is 2x. That product is 4x. 4x and 2x gives me 6x, so it checks. So if the third term has a positive, assuming the lead coefficient x squared is 1, has a positive 1 there, if the third term is positive, then the signs here are going to be the same, and they're going to be whatever the middle term is. So if this is a plus there, this will be a plus and a plus. If this had been a minus 6, this would have been a minus and a minus. Now if the sign of the third term is negative, these signs will be opposite. One positive, one negative. And that what's going to determine what arrangement you have, it will depend on what you want to come up with, a positive middle term or a negative one. So now we have x squared plus 7x minus 8. So we always assume it's factorable, and if there's no combination of numbers that will give us the factored form, then you say it does not factor or it's prime. So we know that if this factors, this should be x, and this should be x. And then if we're looking for factors of 8, they will multiply to give me 8 and add up to the middle term. So we have 8 times a negative 1, 8 times negative 1, or it could be a negative 8 and a 1. We have 4 times 2, 4 times, and then I get 1 would have to be negative here. But we already have it, because 8 and 8 times negative 1 is a negative 8, and 8 and negative 1 is positive 7. So this one here then should be a plus 8 and minus 1. Double check using your form method. So multiplying the first terms, x times x is x squared. Multiplying the outer terms and the inner terms, so 8x. And a minus x is 7x. And multiplying the inner and the last terms, or the last terms rather, 8 times minus 1 is a minus 8. That checks. That's your factored form. And the next one, x squared plus 7x plus 6. This is a 1 here. So we want factors of 6 that add up to 6, then multiply to give you 6 rather, and add up to 7. So for this one we have possibility 6 and 1. We have, this should be 3 and 2, or 2 and 3. So we want two numbers and multiply to give you 6 that add up to 7. In this case 7x. Well, We know the x squared here, or the x has to be there, the x has to be there. If this third term is positive, both signs will be whatever the middle term is, so this will be a plus and a plus. And then we need then a 6 and a 1, and a 1 with a 6. In this case, it doesn't matter which order you put them in there. 6 and 1. You can see x times x is x squared. 1 times 6 is 6, and then in here 6x and 1x is 7x. That's your factorization. Go to number 13. So let's assume this thing factors. So 1 there. So we know this is going to be, if it factors, now if the third term is negative, which it is here, then these signs are going to be different. You're going to have a plus, or minus and a plus, or a plus and a minus. And then we're going to want factors of 12, then multiply to give me a negative 12, and add up to negative x. So once you start working with this, especially these types, it should come fairly easy. 4 and 3. X times x squared, 3 times minus 4, or minus 12. Then check for the middle term, minus 4x here for these, and then 3x, that's minus x. That's your answer. So when you first start off, factor it and then mentally factor it, multiply it back out to make sure it checks out. So this one is a little bit different. The coefficient of the x squared is not a 1. We don't have to focus necessarily just on the minus 8. But the numbers are kind of small. There are other ways to work these kind of problems. For when the numbers are that small, you should be able to get the correct combination of factors. 3x squared, the only way that's going to factor out is 3x and x. That's the only combination. You got to have an x term and an x term on each parenthesis. So I can't leave this one 3x squared and this one x. It's not going to, or 1 rather, it's not going to work. So there we have it. And the signs of this, the third term is negative. So I know these signs are going to be different. So I have to have a plus and a minus, or a minus and a plus. So we know we have to use factors of minus 4. So let's see, we could put a 4 here and a minus 2 here, and see how that comes out. X times 3x is 3x squared, minus 2 times 4 is minus 8. And then we check in here at 4x here, and then this product over here, that's a minus 6x. 4x to minus 6x does give us a minus 2x. So this is the way it works. Now, had you had the signs different here, you had a minus and a plus, then your sign would come opposite what this is. So if the only difference is the sign, just come back over here to the parentheses and switch the signs. If you had a minus and a plus here, then change it to a plus and a minus. Now we have x squared plus x plus 1. No common factor. And remember, you have to be looking for common factors also, not only on the binomials, but also at trinomials. But so far, we haven't had anything common to factor out. Same thing with this one, x squared plus x plus 1, nothing to factor out. So the only way this is going to factor is, okay, x squared has to be an x and an x. Third term is positive, so both signs have to be the same, whatever the middle term is. So the middle term is plus, so this has to be a plus. This has to be a plus. The only factors of 1 are 1 and 1 that we can use. But if I multiply this out, x times x, x squared, 1 times 1 is 1. Okay, this is 1x, and this product right here is 1x. Add it up, and I get 2x. Now, had this been a 2, then this would be factorable. This is one of those that is not factorable. So, depends what they tell you. Some will tell you to put not factorable, or write down prime factor, or trinomial does not factor. This factors into. So we assume it's going to factor. No common factor, so we leave it the way it is. We know 3x squared, the only combination there we can use, it's going to be x and 3x, or 3x and x. That's it. The third term is positive. Both signs in the parentheses will be whatever the middle term is, so it's plus. Put a plus and a plus. This is the only combination we can have. Does it work? X times 3x is 3x squared. 1 times 1 is 1. Okay, for this product, that's 1 times x is x. 1 times 3x is 3x. So x and 3x is 4x. That one checks. Now this one, they're asking you really to factor this out by grouping. Now, I don't have to use it in this form, but there's certain problems where you do have to use grouping. So they try to introduce you to it. So we have 3x squared minus 3x plus 2x. Now, I could just say, well, minus 3x and 2x is minus x, or minus 1x. And this would be a regular trinomial. You can factor it just like the ones we've been doing. But they want you to do it this way. So what we're going to do is we're going to group. We're going to put these together and look for a common factor here. So we can see, okay, we have a 3x common to both and an x. So let's take out a 3x from the first two terms. So if we take out a 3x there, that leaves me with an x. Take out the 3x, that leaves me with a minus 1. Check. If you multiply 3x times x, it's 3x squared. 3x times a minus 1 is minus 3x. No problem. And then the next two, you have 2x minus 2. Well, you can see that there's a 2 in common with both of those terms. So here we're using the common factor method. Factor out of 2 from the second one, so this should be a minus 1. So now look, these two, just look at this first one like a term, and this is a term. What do they have in common? X minus 1. So take out the x minus 1. So we're using the common factor method twice here. Here to get this, and now x minus 1, x minus 1. Take out the x minus 1. What's left? Well, in the first group we have left a 3x. Bring down the plus. And in the second group we have left a 2. We took out the x minus 1. So the factorization for this one would be x minus 1 times 3x plus 2. Okay, on number 18, we have a 3x in common. So for number 18, take out 3x. And what do we have left? Okay, 3x out of this one will leave me with a 3x minus 2. Because this 6x factors into 3x times 2. We take out the 3x, we're left with a 2. And of course the minus is there. And then plus, you have 3x minus 2. Well, if I bring that out, remember that could be multiplied by 1. So if I take out the 3x minus 2 from that, that leaves me with a 1. So let me write it this way. 3x minus 2 can be written as 3x minus 2 times 1. Now we take out the 3x minus 2 from both groups. Common factor is 3x minus 2 here. Put it in parentheses. What's left? Okay, so we're taking this out and we're taking this out. We have left 3x plus 1. So for number 18, factor into 3x minus 2 and 3x plus 1. Number 19, I have x to the fourth. Okay, so we're grouping these two together. What do we have? Let's take out an x squared out of that one. Or I should say x cubed. Take an x cubed out of that, we're left with x. Remember the x cubed can be, a coefficient is 1, so if I take out an x cubed, that leaves you with a 1 there. Plus, okay, we got x plus 1. Think of that like a regular term by itself, so let's put it in parentheses. And then you can put it times 1. That's the same thing. Now you can say, okay, I got x plus 1, x plus 1. Factor out the x plus 1 from both terms. What's left? So if I take this out, and this out, that's run out, then I got put in parentheses because it's a factor. This is x cubed plus 1. So we took out a common factor of x plus 1. And see, notice, this one right here is not necessarily like 17 and 18, because in 17 and 18, we could have added those middle terms and just factored a trinomial. Notice here we can't do it. I can't add the x cubed and the x together because they're different. So here I had to do it this way. Are we finished though? Always look at, once you do one step, look to see what you have left. So we have x cubed plus 1. That's a sum of cubes. So we know we can factor it. The first factor would be the sum of the cube roots, so it's x plus 1. 1 is a cube. 1 to the third is 1. And then the second factor will be the square of the first one there, so this will be x squared Then it's minus the product of those two cubes. So let's see, 1 times x, 6x, plus 1 squared is 1. This is really the answer. But you can say x plus 1 times x plus 1, that's the same thing as x plus 1 squared. So you can rewrite it if you want as x plus 1 squared times x squared minus x. Plus 1. X plus 1 squared times x squared minus x plus 1. And this will be your complete factorization. This should be acceptable, but this is a little bit more simplified here. Let's clear this. Now the third one is another one, or the number 20 rather, is another one where it doesn't work like the earlier ones. Again, I can't just add these. I have to do grouping for this one, because I can't add the x squared with the 2x squared with the minus x. So what I do here is say, okay, the first two, group the first two together, and I'm going to take out a factor of x squared from that one. So what's left from the first two terms, x cubed plus 2x squared, if I take out the x squared, well, I'm going to have an x plus 2. Check it out. X squared times x is x cubed. X squared times 2 is 2x squared. That checks. Now, when you're doing this type of situation, this type of factoring, the whole idea is that you want both groups to have a common factor. So here's a minus x minus 2, but see, this one has an x plus 2. So how can I get that out of this one? Well, take out a negative 1. Okay, now both groups have a common factor of x plus 2. Take out the x plus 2. Factor it out. What's left? Well, took out the x squared, x plus 2 there. I'm left with, put it in parentheses, it's a product. I have x squared. Then you got the x plus 2 from the second term. That leaves me with a minus 1. Okay, that's a product, so that's factored out, but is it completely factored out? And it's always implied when you have a problem that tells you to factor. Sometimes they'll specify factor completely. So you keep going until you can't factor anymore. Well, x squared minus 1, you know it's a difference of squares. So we bring down the x plus 2. And then difference of squares factors into the difference in the sum of the square roots. So the square root of x squared is x. Square root of 1 is 1. So it's x minus 1. And x plus 1, or x plus 1 times x minus 1. The order doesn't really matter there because it's multiplication. That's your solution. Now I want to point out, okay, there's more involved problems that we could do. This is the basic here. You should know this at 8th grade level. If you're going into Algebra 1, Algebra 2, you should know these. If you're going to take college algebra in college, you should already know this. But what's coming up? Later on, you solve quadratic equations. Yet you can solve some quadratic equations by factoring. If they don't factor, you can use quadratic formula, method of completing the square. You can simplify rational expressions. That's basically a polynomial over a polynomial. Something like this. Just to give you an example of one application you could have. You could have, say, something like this. Say you have x squared minus 9. You're supposed to simplify or reduce, just like if you had, say, 4 over 8 with numbers, fractions. 4 over 8, teacher tells you to reduce it or simplify it. So you can see that 4 is the same thing as 4 times 1. 8 is the same thing as 4 times 2. These divide out, and you're left with 1/2. And of course, you don't have to go do this much. If you can see that 4 divides into 8, you can say, okay, 4 is half of 8. 4 over 8 is equal to 1/2. But sometimes with rational expressions, you can't always do that. So for this one, if they ask you to simplify, well, you would go ahead and factor the numerator. X squared minus 9, this difference of squares, that factors into x minus 3. Over x plus 3. X squared plus 3x, common factor of x, take out the x. That leaves me with x plus 3. And then just like over here with numbers, you can say, okay, I got a factor in the numerator of x plus 3. So this divides out with this one, or cancel. This divide out to give you 1. So what's left? I got left x minus 3 over x. And that would be your simplified. So that's an application of factoring. Just one, okay? Adding and subtracting rational expressions, you would use factoring, like I said. Solving not only quadratics, but other types of equations, you would utilize factoring. So, hope this helps you out. Thanks for watching. We'll see you next time. So here's an overview of the answers, just in case problems reading my scribbling here. We'll see you next time.